Hello, my name is César Esteban, and I'm the Field and Support Manager in KDPOF. Today, I'm presenting about the innovations and optical fiber benefits in automotive and industrial markets. KDPOF mission is to lead a revolution in the high-speed optical communications market driven by robustness, low price, reliability, and easiness of use. Our vision is focused on the customer, rethinking the technology, and make a simpler and more robust implementation of the products. Our values are the excellence, the transparency, and horizontal management inside the organization. The history of KDPOF starts in 2010, when the company was incorporated in Madrid, Spain, where the headquarters have been from the very beginning. In 2014, KDPOF taped out its first silicon, and 1 year later, the company was qualified for ISO 9001. In 2016, KDPOF released the world's first gigabit Ethernet plastic optical fiber PHY, complying with AEC-Q 100 automotive qualification. 2 years later, in 2018, the first Ethernet standard was published, and the standardization process was led by KDPOF. Currently, KDPOF has commercial presence mainly in Europe and in Asia. NG-based AU is the automotive optical multi-gig Ethernet physical layer according to the future IEEE 802.3 CZ standard. It is a high-speed PHY supporting 2.5, 5, 10, 25, and 50 gigabit per second over OM3 multimode optical fiber. It uses PAM2 modulation and PAM4 for the case of 50 gigabit per second and Reed-Solomon encoding. It has been designed for high performance with the temperature range going from -40 up to 125 Celsius degrees, and the cable length can go up to 300 meters or 40 meters with up to 4 inline connectors. One of the design requirements of this technology has been the reliability from the very beginning. The transceivers are based on 980 nanometer VCSEL that have been developed to fulfill automotive reliability requirements with 15 years between failures. New connectors have been designed for bending-sensitive OM3 fiber. The whole solution comprises multimode fiber, optical cables, and automotive optical connectors. These connectors comply with the automotive requirements such as scoop-proof, connector position assurance, no clipping mounting, and rugged solution in general. Regarding the standard timeline, the IEEE 802.3 ZZ, the call for interest was issued in the summer of 2019, and a few months later, the study group was formed. In 2020, the project authorization request was issued and the task force was formed. Later, at the beginning of 2021, the first draft was reviewed. 1 year later, in 2022, it was the working group ballot and the SA ballot. The standard is expected to be published in May 2023. With this comparison table, we will understand why a new physical layer specifically for multi-gig in automotive has been developed. On the left column, you see the parameters for the automotive NG-based AU, while in the right column, you have the one for the NG-based SR for datacom applications such as data centers. Reliability is key for this application in automotive. While datacom transceivers do not specify any reliability, the automotive transceivers guarantee 15 years of operation with less than 10 feet. The link budget for automotive is much higher than for datacom. That guarantees the use of low-cost connections. Data centers environment typically have reduced temperature range, while environment in automotive requires from -40 up to 125 Celsius degrees. Regarding power consumption, the automotive physical layer supports full LPI implementation at all speeds. OEM low-speed service channel is supported by NG-based AU, while this requirement is not needed for data center applications. NG-based U will comply with automotive requirements in terms of electromagnetic compatibility, while NG-based R do not have specific requirements for that. Moreover, the automotive physical layer will support mechanical and chemical loads. Both automotive and datacom transceivers will support 300-meter transmission. However, only automotive ones will support 4 meters with N-line connectors. Apart from the automotive application, the new optical multi-gig transceivers can be used in several use cases. Several markets and applications can benefit from the extended temperature range, the reliability, the mechanical robustness, and other features of the new optical multi-gig technology. Let's mention avionics, transportation, industrial applications, communications, energy plants, healthcare, security, and so on. So, what's your application? Can NG-based SR help? If not, you can contact us.